Welcome back to You Revise, where we talk about everything exams. Let's take a look at question 13 from the 2016 exam. It reads, nitric acid can be manufactured from the element nitrogen using the steps below. So we've got step 1, 2, 3, 4. The question reads, the smallest change in the oxidation number of nitrogen is found in, so you're required to say whether it's step 1, 2, 3, 4, which has got a smallest change in oxidation number. Now, because we're talking of oxidation numbers here, this question required you to know the rules for assigning oxidation numbers. Depending on how your teacher gives you these rules, I've seen, the rules can be broken down anywhere between 1 to 7, right? But usually in my class, I've reduced this to 6 because you can actually chunk up or, combine some of those rules. Now, with the rules or things that you have to remember like this, my advice is you need to, if you're struggling to remember them, you can. I don't think you don't need to. You can actually use flashcards where you design nice, beautiful flashcards. As you are writing the flashcards, you don't type them. I know I'm so much against typing because I think the neural connections come up better when you are using your hands to write things down on paper than when you are typing. So as you are writing as well, you are engaging your kinesthetic part of learning. So you are moving your hands, you are interacting with that. And then you can use those flashcards to actually, consistently revisit the rules and learning them again and again and again. Regardless of what people think and say out there, right? People expect, for example, teachers to come up with methods where they teach students and students understand things all at once. I understand there's certain concepts that are very easy that students can, pick up from just being taught once, but a human brain works through repetition. So the more you repeat, right, things, the easier it is for you to remember and understand them. One thing I realize with my students is what I would like to call the law of familiarity. I don't know if that law does exist out there. I just think I'm making it up or I've seen it somewhere, I don't know. But you give a student something, they say, oh, we've done this before. Okay, so can you answer this question for me? No, I can't answer the question, but I've done it. Doing or seeing something that looks familiar and understanding something in such a way that you apply it to answer questions is two different things. Now, moving on, according to the examiner, 64% of candidates got this question right. So what I'm going to do, I'm going to be mentioning some of the rules that you need to know here, and you can go and look at the rest of the rules if you tried out this question and you realize that, no, I couldn't remember some of these rules. My advice, use flashcards, revisit these things over and over again. The fact that I remember these rules from the top of my head does not make me a smart person. No, it's just that I've seen this for over 20 something years. I don't know how many years of, I could say, yeah, 20, 30 something years, whatever the number of years I've seen this. Even if you give this information to a parrot to see it every day, and that parrot could actually recite that information back to you in style. Now, looking at this question here, what do we have? We've got the first step where nitrogen is forming ammonia. So the oxidation state of nitrogen here is 0. The rule I'm applying there is any molecular elements or simple elements will have an oxidation state of 0. That's the rule we are applying here. Now, we need to figure out the oxidation state of nitrogen here. We don't have a rule for assigning oxidation states to nitrogen. So I'm going to say this one here, I'll give it an unknown value, which is X. And we have a rule for assigning oxidation states to hydrogen. It says the oxidation state of hydrogen is always +1, except when it's in a metal hydride. So when hydrogen is bonded to a metal, its oxidation state is not +1, it's -1 instead. So this one here, hydrogen is bonded to nitrogen, so its oxidation state is +1 because nitrogen is a metal. Now I need another rule to finish off this. The third rule that I need to apply here is the compound rule for a compound, which says all compounds, if the sum of oxidation states of elements in a compound is 0. So what it means is if I add the oxidation states of all these elements in this compound, that must be equal to 0. So from there I can form an algebraic expression as this. Nitrogen has got an oxidation state of X, which we don't know, plus we've got 3 hydrogen atoms, which each one with an oxidation state of +1. So if I say 3 times +1, right, that must be equal to 0. So in this case, X plus 3 is equal to 0. Therefore, X is equal to -3. So in this case, in step 1, nitrogen went from 0 to -3. If you go, you could just actually count up or count down. So on the number line, if you start from 0 and you go -1, -2, -3. So this is a change of 3, right? This is a change of 3. So this one, I'll put 3 there. That's the change in oxidation number. It has changed by 3 steps. Now, if we go to step number 2, let's work out step number 2. Because we've worked out the oxidation of nitrogen in ammonia, it doesn't change because now ammonia is doing a different process. The oxidation state, as long as it's ammonia, the oxidation state of nitrogen remains the same, which means the oxidation of nitrogen here is -3. But in nitrogen monoxide, we have to apply the rules again. There is no rule for assigning an oxidation state to nitrogen. Once again, we give it X. The oxidation state of oxygen is -2, right? And that's the rule. It's always -2, but there's an exception to that rule, which says except when oxygen is bonded to a highly electronegative fluorine or when it's in a peroxide. So oxygen can either have an oxidation state of -2, +2, or -1. -2 is when it's bonded to any other element that is not for fluorine and when it's not in a peroxide. +2 is when it's bonded to a highly electronegative fluorine atom, and -1 is when it's in a peroxide. So in this case, this is -2. We applied the same rule we applied for the compound because nitrogen monoxide is a compound whereby the sum of oxidation states here must be equal to 0. So if we say X plus -2 is equal to 0, X minus 2 is going to be equal to 0. X is equal to +2. So in this case, oxygen went from -3 to all the way to +2. So if you want, you can just say +2 minus -3, which gives you it moved 5 times. The change is 5. Or you can go on a number line and start from -3 and count all the way to +2 if you want to use a number line, but you could just simply apply algebra to say, okay, subtract these numbers and see what was the change, where it started to where it ended. So it's just got a change of 5 there. Now, C, step number 3. We've got nitrogen monoxide. Here we've already worked out that this one is it's +2 here. Right? Nitrogen is +2 in nitrogen monoxide, but in nitrogen dioxide, the apparent charge, which is the oxidation state of nitrogen, is going to change. Oxygen is still -2 because nitrogen dioxide is not a peroxide. Nitrogen is not fluorine, so the +2 and -1 oxidation states for oxygen don't apply here. So we do the same. Nitrogen here is X. and we apply the rule for a compound, which say the sum of oxidation states here must be equal to 0. So if I say 2 times minus 2, we get -4 plus x is equal to 0. X is going to be equal to +4. So x, in step number 3, we went from +2 to +4. That's how the oxidation state changed. So these are just 2 steps, right? If we do the maths there. And then the last one, step number 4, nitrogen dioxide, we've already worked this one out, right? The oxidation state of nitrogen is +4 here. But now let's take a look at it in nitric acid. Nitric acid, oxygen has got an oxidation state of -2 because this is not it's not directly bonded to fluorine, number 1. Number 2, it's not a peroxide, so those other oxidation states don't apply here. And nitrogen will be X. Hydrogen is always +1 because in this compound it's not bonded to a metal, number 1. Number 2, it's not bonded to a metal. That's just it, because it has got only one exception. My bad. Now, so if we apply the rule for a compound here, we would say the sum of oxidation states here should be 0. So if we say X for nitrogen plus 1 for hydrogen minus 6. Where am I getting minus 6? If I say 3 lots of oxygen, each one with an oxidation of state of -2, 3 times -2, we get -6. So that gives me +1 minus 6, it gives me -5. X minus 5 is equal to 0. Therefore, x is equal to +5. So here we've gone from +4 to +5, which means there's only a change in oxidation state of 1. This gives us D as our correct answer. Okay, once again, if you are struggling with this and you are struggling remembering the rules, use flashcards. Another question actually that I've just thought of, I think I need to address here. What's a peroxide? How do you know that oxygen is in a peroxide now? The common peroxide you're going to come across in this course is hydrogen peroxide, H2O2. Now, a peroxide is just a normal oxide plus an extra oxygen. So the normal oxide of this is H2O. So to turn this to a peroxide, we've added an extra oxygen. It's H2O2, right? Let's say I give you sodium oxide. Sodium oxide is like that. If I add an extra oxygen there, sodium peroxide will be, we add an extra oxygen, that would be sodium peroxide. So a peroxide has got an additional oxygen. If you know the normal oxide, to get the peroxide, you just add an extra oxygen. So if it looks like an oxide, you know, and then it has got an extra oxygen, that means it's a peroxide. Okay. This is what I tell my students, but generally this is the peroxide you're going to come across, hydrogen peroxide, H2O2. I hope the extra explanations and all the other things that I said in this video will come in handy in your revision and the tips that I've offered. I shall see you when you attempt the next question. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I'd love to hear any questions, any concerns, or anything that you think could have been done differently in this video.